NASA confirmed Thursday that the Voyager 1 probe has made history by becoming the first human-made object to leave our solar system.
Most likely you would sort a mnemonic to help you recall the planet's position in our solar system. Remembering the order of Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, and Pluto was made simpler and more accurate by doing this. Of course, after that, scientists went and really fouled everything up by depriving Pluto of its status as a planet. Will the solar system need to change again after that? You can't be sure. It might need to be modified once more as a result of a recent scientific advancement. Did you know that there is a planet between Mars and Jupiter, for instance? Astronomers believe there might be a planet missing between Jupiter and Mars's orbits after studying the planet's trajectories. In fact, this cluster of big and little stony particles is the asteroid belt. What led to its formation? Could this possibly be the lost planet? Let's find out. Our Sun's most impressive collection of space pebbles is located just outside the orbit of Mars. Science fiction writers and scientists alike have been enthralled by the asteroid belt, considering the potential for extracting ore, water, and other resources from the area to advance future space exploration. But how did this debris ring in orbit come into being? Does it resemble the rocky remains of a long-gone planet, or a sort of gathering spot for a planet yet to be? Over the years, scientists have evaluated the viability of both reactions. A large ring of space pebbles, on the other hand, is unlikely to become a whole planet in the relatively near galactic future, according to more recent theories. Why? There isn't enough content there, plain and simple. Our solar system wasn't at all steady or ordered billions of years ago. While planets were still developing, they threw off the orbits of their neighbors. Because of all this activity, some scientists once thought that the asteroid belt that is floating in space now was created by the fragmentation of a planet that orbited our Sun between the paths of Mars and Jupiter. However, it became evident they didn't originate from a single parent body when scientists started looking at the patterns in iron meteorites that landed on Earth as meteors. As a result, the belief that the asteroid belt is replete with planetesimals, i.e., fragments of planets that either haven't formed or have failed to form, started to take hold. The problem with this notion is that the belt just doesn't have enough material to support such a mass. The asteroid belt wasn't discovered until the middle of the 19th century. However, scientists had been searching for a planet in the region between Mars and Jupiter for a long time before that. Johann Daniel Titius, a German astronomer, suggested the following theory in 1766. Extending outward from the center of the solar system, each planet should be located approximately twice as far from the Sun as the planet before it. This theory, now known as the Titius-Bode law, proposed the existence of a planet between the orbits of Mars and Jupiter that had not yet been found. This concept sparked the obsession of many people. For instance, a huge international initiative to identify the missing planet was launched by a group of German astronomers known as the Celestial Police. Giuseppe Piazzi, an Italian astronomer, found Ceres in 1801, outpacing them in the process. This heavenly body was found to be almost exactly at the distance that the Titius-Bode law anticipated. Ceres was, of course, once thought to be the missing planet. However, other comparable objects were quickly discovered nearby. As more astronomical objects between Mars and Jupiter were discovered, it became clear that they were all too tiny to qualify as planets. The name asteroid was first used by William Herschel, who discovered Uranus, and it became widely used. Asteroid belt first appeared in usage in the 1850s. The largest asteroid in the belt is Ceres, which is about the size of Australia and has a mass that is less than half of the entire belt. Scientists didn't give up on the notion just because the asteroid belt doesn't appear to be the remains of a past planet. The belt may have originated from fragments of now extinct planets, or a planetesimal, or baby planet that was never fully formed before being shattered. These fragments might have been leftovers from the formation of Jupiter and Saturn. These planets may have traveled through the solar system at a later time before arriving in their current orbits. A dynamic instability with chaotic orbits and gravitational forces would have evolved from this. Asteroid belt material does not originate from a single source, as we now know. It's possible that some of its constituent parts came from the broad region of space it currently resides in. Other materials might have originated from places outside of Jupiter's orbit. Other asteroid fragments that broke off at some point may have come from the inner planet zone during the early period of instability in the solar system. The motions of the planets may have caused some asteroids to be drawn in by the gravitational pull of Saturn and Jupiter, while sending other asteroids hurtling into other planets, or out of our solar system entirely. Some scientists even contend that during this time, asteroids rich in water collided with Earth, forming the oceans that exist today. A portion of these objects might have been launched at the proper velocity and trajectory to enter the asteroid belt. The asteroid belt is sometimes referred to in this context as the solar system's blood spatter. These fragments may have been sent to the asteroid belt by violence, but they remain there because Mars and Jupiter's orbits finally became stable. So even if an asteroid manages to reach that region, it most likely won't move. Most astronomers are interested in learning how the planets evolved in the solar system. Asteroids continue to provide information about the planet's distant history through their composition, location, and orbits. Ceres, now known as a dwarf planet, is a tiny world with a tremendous surprise. Numerous studies from NASA's Dawn mission strengthen the argument that Ceres is a geologically active world with ice, volcanoes, and pockets of an ancient ocean that have survived. The dwarf planet likely has a briny liquid seeping out on its surface, as well as mounds and hills that formed when the ice melted and refroze after an asteroid impact about 20 million years ago, according to about a year's worth of data collected by Dawn from late 2017 through late 2018 during its final orbits before running out of fuel. It originally would have appeared impossible that liquid water could survive on Ceres, a world that is only a third as wide as our moon. The chilly small Ceres is geologically active, though. Now that humanity has seen it up close, the information clarifies the riddle surrounding a crater, a 57-mile-wide impact crater on Ceres that is coated in puzzling bright salt patches. According to the current research, these salty deposits were likely created by the oozing of a cold subsurface salt water over a crater's floor as recently as 1.2 million years ago. The concept that Ceres encounters a type of ice-cold cryovolcanism with briny mud slush functioning like molten lava does on Earth is supported by the planet's bulging ridges and hills. Dawn noticed indications that brine had leaked from ice volcanoes within the previous few decades, if not more recently, in one area of the crater floor of a crater. Beyond strange volcanoes, the discoveries add Ceres to the growing list of planets that formerly contained liquid water, energy, and carbon-containing organic molecules, all the elements needed for life. Scientists believe that Ceres may have been habitable, though not necessarily inhabited, for brief periods during the heat of asteroid impacts. Scientists have been mystified by a crater's bright patches ever since Dawn discovered them in 2015. The features in the crater were made of salts, which scientists immediately discovered were probably deposited there by brines that seeped up onto Ceres's surface. Where did the brines come from? Is the query. A crater is estimated to be 20 million years old. Massive amounts of heat would have been produced by the impacts that gave rise to it, turning the typically chilly environment into a foamy bath of churning salt water. However, the Dawn team discovered that the heat from the collision largely dissipated within 5 million years or so, using computer simulations. It is impossible for the impact to have caused some of the salty bright spots because they were formed during the last 4 million years. Instead, the liquids must have originated from a deep, old brine reserve. Because a planet's gravitational pull can vary somewhat from place to place, depending on the surrounding terrain and crust density, Ceres gravity indicated the brine's likely sources. By detecting minute variations in Dawn's velocity as it orbited Ceres, scientists were able to follow this variation there. Researchers discovered that the Earth beneath the crater was less dense than the surrounding crust. When they paired this information with Ceres topography below the crater, two brine pools that are like huge M&Ms look to be ellipsoids. The larger one is 260 miles broad and is located 30 miles straight below the crater at the crustal base of Ceres. 12 miles below the surface, to the southeast of the crater, is a smaller briny reservoir that is about 120 miles wide. Asteroid crater was likely formed as a result of something striking Ceres, which also likely sparked the icy volcanism that transported briny material to the surface. Cryovolcanoes on Ceres, unlike volcanoes on Earth, form when ice in the dwarf planet's crust freezes, expands, and presses pockets of subterranean brine. The crust of Ceres was broken by the Asteroid impact, leaving cracks that deep brine may use to rise to the surface. Upon spilling out, the water evaporated, leaving the present-day brilliant salty deposits. Even some observations imply that Ceres activity is still ongoing. Scientists' conceptions of geology of dozens of other worlds have been stretched by the discovery that small icy bodies are significantly more active than previously assumed by NASA's New Horizons and Dawn missions, which passed by Pluto in 2015. The new James Webb Space Telescope, JWST, from NASA is receiving a lot of attention. It's justified because the probe is anticipated to be the following generation Hubble. In actuality, it has imaging power that is almost 100 times greater than the Hubble telescope. The JWST will be able to look farther into the past than any other telescope. The JWST may someday provide the answers to all the questions concerning the asteroid belt, and it might also provide insight into one of astronomy's current mysteries, the enigmatic Planet 9. Many people were forced to reconsider their beliefs about the solar system when the number of planets in the system was lowered from 9 to 8. It got worse when it was revealed that, at the beginning of 2016, a massive ninth planet that had never been seen before might be orbiting the Sun. For those of us that are still reeling after the loss of Pluto, understanding Planet 9 has been a little difficult. The hypothetical planet was given the name Planet 9 because, if discovered, it would replace Pluto as the solar system's ninth planet. The next planet is also referred to as Planet X, Planet Next, or Giant Planet 5 because some scientists and members of the public still refer to Pluto as the ninth planet. It's crucial to note before we continue, according to NASA, Planet 9 presently only exists in theory, so don't start redoing your solar system maps just yet. Planet may 9th be 10 times the size of Earth and orbits 600 times further from the Sun than the Earth does on average, according to current projections. Powerful telescopes like the James Webb Space Telescope are currently being employed by astronomers all across the world in the search for Planet 9. If such a planet existed, it would be positioned many billions of kilometers beyond that annoying dwarf planet Pluto, in the region of the Kuiper Belt that receives very little light or energy. According to both facts, Planet 9 originated along with the other planets in our solar system billions of years ago. In this case, the planet originated significantly nearer to the Sun when the solar system was still developing and planets were only starting to form from the surrounding gas and dust. Before being scattered by Jupiter or Saturn, it lingered close to the region where large planets form. Later passing stars affected its orbit, and it only stayed long enough to stir things up before vanishing once more. Nevertheless, visual confirmation is still necessary before it can be formally recognized as a known planet, despite its size and orbital pattern. The majority of scientists concur that Planet 9 was an ice giant core that was ejected from a much smaller orbit during the chaotic formation of our solar system. This naturally begs the question, if Planet 9 exists, why hasn't anyone seen it? Researchers are confident that Planet 9 exists, albeit discovering it could take years based on their tracking of its gravitational pull through the Kuiper Belt for a variety of reasons. Scanning an orbit pattern with a 10,000 to 20,000 year period can take a while. It would be more challenging to track this hypothetical planet's movement, since, at its furthest distance from the Sun, it would not exert any gravitational pull on the other planets. Because of this, only about half of the orbit falls inside the searchable zone, making the search a lengthy guessing game. It is very difficult to identify because of its great distance from the Sun and the lack of any light it emits on its own. There is cause for optimism in the search for Planet 9 though. Planet 9 is too far away from where it is assumed to be seen from that area. However, a 10-year study of the skies will start this year at the Vera C. Rubin Observatory, VRO, in Chile, which went online in 2021. This will probably lead to the discovery of thousands more Kuiper Belt objects. Close examination of their orbits may be able to confirm or deny the existence of Planet 9, as well as provide details regarding its origin and location. Deep in space, the JWST